Good morning, class. So today we are going to talk about two terms, bioaccumulation and biomagnification. And both of these terms are related to each other. So I'm going to go through what these terms mean with respect to the ecology unit and ecosystems. So this diagram just shows you basically how certain toxic metals, pollutants can get into a food web or a food chain by being discharged by certain industries, okay? Many different types of industries will pollute waters, pollute soil, and these pollutants basically get into food chains and food webs. And as they are consumed by microorganisms like on this side over here, for example, phytoplankton, they are consumed by larger and larger organisms and can have a negative impact or effect on these larger organisms over time. So basically, bioaccumulation refers to how pollutants enter a food chain. It's basically the process by which materials, especially toxic materials or toxins, are ingested by an organism, and it is ingested at a rate that is greater than that toxin is or can be eliminated. Nutrients are basically simple compounds that are used, broken down, and recycled by organisms. All organisms need these simple compounds. They need to consume them, they need to be able to break them down, and they need to have them there in place for many different types of biological reactions that take place within the cells, within the bodies of organisms. And then when these organisms die, they need to be recycled, and this whole process takes place again. So pesticides, on the other hand, are not simple. They are complex compounds, and they are actually designed or specifically engineered so as to not break down. They are basically built to become persistent. And therefore they will eventually kill organisms, and they are meant to kill organisms. And because pesticides do not break down easily, they accumulate in the bodies of organisms, and they will eventually move up the food chain as those organisms are consumed by larger organisms and so forth. So pesticides, there are different types of pesticides. There's basically there's insecticides, which kill insects. So an example of one such insecticide that is now banned is called DDT. Herbicides, which kill plants and basically weeds. Roundup is an example of a herbicide that is now banned in Canada. I think it's been banned about 10 years now, but you can still purchase this. Actually, my neighbor purchases this Roundup on the left side here from the US, and his grass is always spectacular. There's never a weed. It's way prettier than our grass, but it has been linked to many types of cancer. And actually this lady over here and her husband, they won, I can't remember how many millions of dollars, a legal battle because they both got cancer, and they basically fought against this company, suggesting that they were using it for 3 decades on their lawn, and they developed cancer, and they blaming it on this herbicide, and they won. Fungicides are pesticides that kill fungus in particular, and Captain is a type of fungicide, and bactericides are those that kill bacteria. And you all know that penicillin is a common, basically it's an antibacterial that kills many types of bacteria. When we get sick with a bacterial infection, usually penicillin is the first thing that the doctor will prescribe. So bioaccumulants, these are basically, these are the toxic substances that we're talking about that increase in concentration in the tissues of living organisms. They basically enter the organisms through the contaminated air that the organism is breathing in, or the water that it is swimming or consuming, the soil or food that the organism is absorbing and eating, and they are very slowly metabolized. Bioaccumulation is basically the concentration of pollutant from the environment which occurs within a trophic level. For example, one level of a food chain, usually the first organism in the food chain. So over time, it's when that organism continues to consume or absorb that pollutant over time, and it accumulates within that organism. Biomagnification is related to a bioaccumulation, but it is the specific increase in concentration of a pollutant that occurs within a food chain as it moves from one trophic level to the next. So basically, when one organism that has contains pollutants or toxins, it is consumed by another organism within that within the next trophic level, and then that organism is consumed by the next organism in the next trophic level. This is where that toxic is becoming magnified, because that larger, higher trophic level organism is going to be consuming many of the lower level organisms that contain the pollutant. But because they're consuming larger numbers of these organisms, that pollutant is become more magnified within the higher trophic level. It occurs when substances such as pesticides or heavy metals, for example, mercury, move up the food chain by working their way into the environment. And it's also another term for biomagnification is bioamplification. It's the same thing. So this diagram just shows you the difference between bioaccumulation. So this is, for example, this is over time. These fish, these same fish are basically consuming or having those toxins absorbed into their body over time. It's the same fish, but it's just over time. Whereas biomagnification, this is happening where the smaller organisms are absorbing or consuming the toxins. These are eaten by the fish. So you have the fish having, and the fish are eating a lot more of these organisms. So they're basically the concentration is increasing within the fish. And then the seal eat a lot more fish that are contaminated. And then so the sea lions become, the toxin becomes even more concentrated, and then the bear or the polar bear is eating the seals, and therefore the amount of toxin within the bear is extremely concentrated compared to what it is in this crayfish over here. So biomagnification, pollutants in rivers or lakes are taken up by microorganisms like plankton, and they are eaten by aquatic organisms such as fish, which in turn are eaten by large birds or animals, and then eventually humans. The pollutants become concentrated in the tissues or internal organisms as they move up the chain. So again here, this is shrimp. You can see over here biomagnification, where it's less, the shrimp is absorbing or eating the by default having the toxins, but it's not as concentrated as all the way up here at the highest trophic level, the polar bear, which there's a lot more toxic substance here concentrated. So as bigger animals eat smaller animals, the level of contamination in the food is added to the level of contamination already in their body. So as it goes up the food chain, from smallest to largest organism, it increases in concentration, thus by biomagnification. So bioaccumulation in action. So there are many ways chemicals end up in lakes and rivers, including wind and rain runoff, okay? So these are some examples: DDT, PCB, mercury, DLC. They basically will be they basically run off from the soil and the rain, and the what's the water that is enters into the lakes and rivers and runoff, and will sink to the bottom of a lake or river, and where they settle in the sediment. And basically small creatures called macroinvertebrates will eat these chemicals as they dig in the sediment and the food. These are then eaten by minnows, these fish right here, by which are medium-sized fish, and fish that are then minnows are eaten by larger fish, each collecting and storing some of the chemicals in their body. And this is why larger fish, predator fish and long-living fish, are likely to have more chemicals in their bodies than smaller, younger fish. So in order for biomagnification to occur, the pollutant must have some qualities, and basically this quality is persistency. So persistent chemicals in action. So the pollutant must be long-lived. That's a typo, sorry. That should be long-lived. It should be mobile. It should be soluble in fats and should be biologically active. So in the 70s, this was where, industrialization was in full swing. Factory puts out a lot of persistent chemicals through the smokestacks. But in 2011, thank God, we know a little bit about, air pollution and acid rain and all that, nastiness that, hopefully we've learned some lessons. But these the smokestacks have been equipped with what are known as scrubbers, and they basically clean the exhaust fumes and the air coming out of these factories, so that their chemicals are not being released by those smokestacks, but the chemicals that they put out in the 70s still actually remain in the sediment, are slowly being released. So there's huge improvement, but because these are persistent, they degrade over long periods of time. They are still there and have an effect on aquatic ecosystems. So pollutants. So persistent pollutant is one that dissolves in fats and are retained over a long period of time. Lipids or fat-soluble substances cannot be diluted, broken down, or excreted in the urine. And they basically accumulate in the fatty tissues of an organism if the organism lacks enzymes to degrade them. Short-lived pollutant basically will break down before it becomes dangerous. If it's not mobile, it will stay in one place and is unlikely to be taken up by organisms. And then if the pollutant is soluble in water and not fat soluble, it will be excreted by the organism. So that's the difference between persistent and short-lived pollutants. So DDT, also, well, this is short form for diphenyl trichloroethane. Basically, it was a pesticide that was once used in North America and basically became banned in the 70s because it was they realized that they were having a very negative effect on certain wildlife. It was entering the environment through runoff from land because it was a pesticide that the farmers were using on land. It would leach into the soil, into the water systems, and microorganisms were like algae were eating the consuming it, and then the microscopic organisms were eaten by algae was being eaten by other larger microscopic organisms, which were being eaten by minnows and larger fish, and then finally fish eating birds, ospreys, for example. And you can see that the concentration, parts per million, how it's going up to 25 parts per million compared to in the water, 0.000003 parts per million. So it was affecting the reproductive ability of these birds. So these birds' population was going down, and then obviously their studies were done, and they were it wasn't long until they would see that the effects of DDT not just on the birds, on these ospreys, but on humans and other organisms, other animals. So they finally banned the use of DDT many years ago. So just looking at how persistent it is, DDT has a half-life of 15 years. So therefore, if you use 100 kg of DDT, it breaks down as follows. So year 0, 100 kg. By year 120, you still have 0.39 kgs left. So these are some examples of other pollutants and toxins. So you probably haven't heard of any of these, but these are phthalates, for example, lead. You've heard of lead. These are also very harmful toxins or pollutants that have negative impacts. For example, these are found in plastics, in those water bottles that were being used. Lots of other plastic containers had phthalates in them. Some shampoos and body washes contain phthalates, and they're known as endocrine disruptors because they affect the normal endocrine function. So hormones that need to be produced at a specific rate are not being produced, or the endocrine glands that are producing the hormones are being overactivated, and too much growth hormone, for example, is being released. So many different types of effects of all these persistent and or bioaccumulative toxins have on our body and our ecosystems. So that is the end of today's lesson on bioaccumulation and biomagnification. I'll be giving you some a little bit of reading in your textbook, not much, and a couple of questions. And I will talk to you again soon. Hope you have a wonderful day, class.